Good morning, sir. Myself, S.R. Kumar Reddy from 2nd CSA. Today, my topic is about copy on write. Introduction to copy on write. Copy on write is a resource management technique used in operating system. It optimizes memory usage by delaying the copying of resource until they are modified. This method is widely used in virtual memory management and file systems. Copy on write is a technique operating system. The mainly used to copy the content of one device to another device or one of the memory to another. Historical background. The content of copy and write dates back the early 1980s. It emerged as a solution to improve performance in memory management. Copy and write has since been integrated into various operating systems like Unix and Linux, memory management system, high performance processors. How copy and write works? Initially, multiple processors share the same memory pages. When a process attempts to modify a shared page, a copy is created for that process. This ensures that changes made by one process do not affect other. Process 1, process 2 and process n. Invocation response. Memory manager. Process 1 is going to memory manager and then receive from process 1 as well as process 2. Process 2 is sending the data to memory manager and again sending to process 2. Then memory manager process and same shared virtual memory. For these, they have to efficient for the user. Do not affect the process of others. Advantages of copy and write. Copy and write significantly reduces memory usage by avoiding unnecessary copies. It enhances performance by allowing multiple processors to share resources. The technique simplifies resource management in operating system. Applications of copy and write. The copy and write is commonly used in virtual memory systems to manage page tables. It is also utilized in file systems for efficient snapshot and versioning. Main programming languages leverage copy and write for optimizing data structures. The copy and write mainly programmers used for the data structures usage. In the figure we have to observe physical page number or disk address, valid, PTE, 0110 and so on, first null. Then we have to assign it to the address, some VP1 or VP2. Then memory resident page table, DRAM, virtual memory disk. It is the physical page is connected to virtual memory disk. Next, copy and write in virtual memory. In virtual memory systems, copy and write allows efficient management of page faults. When a page is not modified, it remains shared among processes. This leads to lower memory consumption and faster content switching. The main copy and write is used for the memory consumption is less and it is works on faster than the others. Copy and write in file systems. File systems like ZFS and BTRFS utilize copy and write for efficient data storage. Snapshots can be created without duplicating the entire dataset immediately. This provides a quick and safe space efficient way to backup data. Performance consideration. While copy and write minimizes memory usage, it can introduce overhead during writes. The copying process can lead to fragmentation if not managed correctly. Benchmarking is essential to evaluate the trade-offs in specific scenarios. Copy and write has minimizes the memory. It has to overhead the writes. The copying process can have may lead to fragmentation process if not managed correctly. Copy and write and multi-threading. Copy and write plays a crucial role in multi-threaded environments. It allows multiple threads to read shared data with minimal contention. Modification triggers copies, ensuring thread safety without locks. Copy and write's crucial role is multi-threaded environment. It have to work on multi-threaded because one thread is not depend on another thread. The thread have work done it's concurrently. If one thread is working, then another thread is also work. The working speed of using thread is very fast. So copy and write is work on multi-threading environment. Limitations of copy and write. Copy and write can lead to performance bottlenecks while many modification occurs. The overhead of copying data can outweigh its benefits in some applications. Careful design is necessary to mitigate these limitations in system. Copy and write performance bottle lead to bottlenecks when modification occurs. The second limitation is overhead of copying data outweighed. Careful design is necessary to mitigate these limitations in systems. Copy and write in programming languages. Languages like Python and Ruby implement copy and write in these data structures. The main language is used to Python and Ruby implement the copy and write. This helps optimize memory usage when handling large data sets. The copy and write mainly helps to optimize memory usage. Handling large data sets it will be handled. Developers can benefit from reduced memory overhead in applications. Data structures in Python. Built-in data structures, user-defined data structures. The data structures in Python is divided into two subdivisions. First one is built-in data structures, user-defined data structures. Built-in data structures have four types: list, dictionary, tuple, and sets. User-defined data structures have stock, queue, tree, linked list, graph, and mind map, hash map. Comparison with the traditional copying. Traditional copying requires immediate duplicate of resource. Copy and write allows sharing until modifications, optimizing both performance and memory. This fundamental difference impacts how application manage resources. Copy and write allows shared until modification optimizing both performance and memory. Future of copy and write. What is the future depends on copy and write. As system evolve, copy and write is likely to be integrated with more advanced techniques. Research in optimizing copy and write for modern hardware continues to grow. The increasing demand for efficient resource management fuels this progress. You have to observe copy and write in the tube like structure. Case studies. Case study of Linux fork system called Showcase Copy and Write in Action. Observations from ZFS highlight the benefits of copy and write in file system. Performance metrics from various applications demonstrate copy and write efficiency. Fork calls. We have to divide the fork into parent and child one. The fork is works for dividing the parents and child. Then parent is again divided into parent and child 2. Then the parent is again divided into parent and child 4. Then we have to parent is happy and child 4 is happy. Fork function is work for the parent and child combination. Conclusion. And conclusion of my topic copy and write is about copy and write is a valuable technique in modern operating systems. Its ability to optimize memory usage and enhance performance is significant. Understanding copy and write is essential for developers and systems architects alike. Copy and write techniques, modern operating systems, we have to use the copy and write. It is very useful for faster and less memory usage. Main data structures involved in copy and write. The ability to memory usage is very easy and significant. It is very easy to use copy and write to the faster data sending or receiving. Understanding copy and write is essential for the copy and write is to understand the developers for doing the projects very quickly and faster. Real-time operating systems, applications, RTDS, right to device system, custom hardware. The application is sent to RTDS and then RTDS sent is to custom hardware. Then the custom hardware is again issued to RDTS and then application. We have to copy and write performance usage very efficiently for the faster programs running and very less memory usage. The threads have been involved in copy and write and multi-threading we have to use for these. Thank you sir giving this opportunity.